Over the past several years, it's been hard to ignore all the hype surrounding the topic of additive manufacturing, more commonly known as 3D printing. It seems like hardly a day goes by without... Hi there, and welcome to 3D Opportunity, the course on additive manufacturing for business leaders. My name is Mark Hotelier, and I'm a research director at Deloitte. You know, over the past several years, it's been hard to ignore all the hype surrounding the topic of additive manufacturing, more commonly known as 3D printing. It seems like hardly a day goes by without some newspaper article or news story hyping the next great advancement in this technology. And we think that's important because this is a key technology for the future. We see additive manufacturing as indeed having a strong impact on the addition of business value for manufacturers over the next decade. But it also leaves managers in a difficult position. It's hard to figure out how to translate the concepts of additive manufacturing from a newspaper article to the actual idea of producing a part that matters in the real world. The aim of this course is to address that challenge. Our goal here is to provide you with the foundational understanding of how additive manufacturing applies within your business. We want to equip you to have a discussion with your boss or your colleagues, your customers or your suppliers in order to help them understand what the path forward with this technology actually is. In order to accomplish that goal, we designed a fairly straightforward course. We'll begin by setting a context for you. We'll define additive manufacturing and help you understand why we think it's important to use that term instead of the more commonly used term 3D printing. We'll also explore the makeup of the industry and provide you with a little bit of history from where we came from. This technology is, after all, over 30 years old. We'll then move on to address two key questions. Number one, what is additive manufacturing? In order to do that, we'll explore 7 fundamental processes with examples of technologies through which we can explore applications, advantages, and disadvantages of each of those processes. The next big question is, how does additive manufacturing apply to my business? In order to explore that question, we'll present you with a framework that explores the underlying economics that impact both products and supply chains, and also explores how those two things come together to inspire new business models. We'll also examine how we can apply the framework to specific industries that have already made strong use of additive manufacturing technologies. We'll conclude by examining some of the issues that impact additive manufacturing technologies into the future. We're excited to have you here, and we're looking forward to getting started. This is home for me. I taught for 9 years on the faculty at the College of Business just across campus. Today I'm here in this beautiful new engineering building because of the commitment that the College of Engineering here has to understanding and applying advanced manufacturing technologies, including additive manufacturing, to the delivery of value for businesses. The purpose of this segment is to begin digging into the idea of additive manufacturing, importantly by defining it. When we look across the additive manufacturing space, or even when we consider the title to this course, we see a variety of terms that are mixed and matched. Most popularly, this technology is referred to as 3D printing. Of course, I'm using the term additive manufacturing. We've also seen it referred to as rapid prototyping, rapid manufacturing, and direct manufacturing. All of these terms refer to this set of technologies. So why do I refer to it as additive manufacturing? Well, let's take a look at the diversity of products that we have in front of us. We have some that are very pretty. We have some that are medically oriented. We have some that look very functional. We have some that are fashion oriented. All of these items look very different to us, but they were all made with additive manufacturing. Now, when we think of the term 3D printing, to me at least, that evokes this idea of maybe an inkjet printer with a print head moving across a sheet of paper, laying down ink, in this case, material in general, to create the finished product. In the case of inkjet printing, that's a piece of paper. And some additive manufacturing technologies do in fact look like that. We're going to explore those in later on in this course. But they don't all look like that. And we want to define the technology that we're using in a way that refers to all of the technologies, not just a few. For that, we turn to the American Society for Testing and Materials, or ASTM. They give us a very specific definition for additive manufacturing. Additive manufacturing is a process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing technologies. Now, there's a couple of things I'd like you to note about that definition. Number one, it's defined in opposition to other more traditional methods. In this case, subtractive approaches to manufacturing. What's a subtractive approach to manufacturing? Think machining a solid block of material, and we're removing or subtracting some material in order to get to our finished object. Another way we could define additive manufacturing in an opposition is to say forming technologies like casting or molding. Our job here is to understand how additive manufacturing technology fits into the general constellation of technologies that we're going to use in order to create value, in order to produce objects. That's the purpose of this course. Now, before we get to that, we want to think a little bit about the history of this technology set. In fact, the technology is almost 30 years old. In 1986, a man by the name of Charles Hull invented a process called stereolithography. We're going to explore that technology in some depth in a later segment. Charles Hull later went on to found a company called 3D Systems, which is one of the largest technology providers in the additive manufacturing space. Now, if we look at this timeline here, we'll see what I call my logarithmic chart, because it really accelerates. The first small bit takes us 20 years from 1986 to 2007, and then things really begin to change. That first 20 years is what we might call the evolutionary period of the technology, where we're slowly making inroads, slowly developing the technology, primarily within the rapid prototyping space. But in 2009, something important begins to happen in the market. The technology patents for the underlying technology set begin to fall off. In this case, for a material extrusion process called fused deposition modeling, which is a proprietary technology by Stratasys, one of the other major competitors in this space. When that happens, when that FDM patent falls off, the technology becomes available to a much broader cross-section of producers, prices fall, and now we have FDM as one of the key, if not the key, underlying technology for most of the consumer additive manufacturing devices that exist in the market today. Now, in 2014, we're seeing another change take place. The fundamental patents for a technology called selective laser sintering, or SLS, are beginning to expire as well. That will open up a whole new area of materials that allow further expansion of additive manufacturing technologies into the market space in ways that some people are predicting will reduce costs and expand availability. How does the underlying process work? As we walk through each of the technologies in the next module, we're going to see a fairly standard approach to the overall process. It begins with a representation of an object as a 3D model in CAD-based software, computer-aided design-based software. That model can be created directly in the software, or it can be input into the software through the use of a laser scanning device that will take a physical object and bring it into the system. Once that design is created, something called an STL file is created. STL stands for Standard Tessellation Language, and it is the most popular file format for additive manufacturing, although there are others, and it's important to know that they exist. We'll use STL for our purposes. To tessellate something, as in Standard Tessellation Language, is to break it down into a series of polygons, in this case triangles, to represent not just its external structure, but its internal structure. That's important, as we're going to see, for additive manufacturing. Once that file is created, the system slices it into many, many different layers, and it passes that information to the additive manufacturing device, whatever that device may be. The AM system itself creates the object, as per the definition, layer by layer until we have a finished object. And then very often, there's post-production required. That might be removal of dust or other material. It might require some machining. It might require a process called sintering, where we're closing out voids, or some sort of infiltration process where we're filling voids within the object itself with other materials. In the end, the goal is the same, to create a physical object from a 3D model. What are the various applications that we can think about for this technology? Let's take a look at it with respect to both industries and the application. Very broadly defined Industries of industrial products and consumer products are the biggest. Industrial products about 19% of the market, consumer products about 18% of the market, at least in 2013. And then the big three more specific industries: automotive at 17%, medical at 14%, and aerospace and defense at 12%. We're going to take detailed looks at each of these three industries and the application of additive manufacturing to them later on in this course. What are the applications? Far and away the biggest, prototyping, 38% of the market. Let's remember that additive manufacturing began as a rapid prototyping technology. Following that, we have tooling, 27%. We don't think about tooling so much, but it's important, and we're going to devote some time to understanding applications in tooling later on the course. And perhaps most important is production parts at 29% of the market. Now, there's something important that I'd like to point out here. If we go back to 2011, we'll see that final part production parts, represented about 19% of the market at that time. In 2013, as I just said, it was 29%. That means that the use of additive manufacturing for final part production is growing faster than an already rapidly growing market. Why is that important? Well, it's important because firms spend about 10 times more on final part production than they do on prototype. So if additive manufacturing really takes hold in final part production, it'll give us further reason to believe that an explosion in the use and growth of the technology is more likely. Where are we going to see it happen? Well, there are advantages and disadvantages to both additive and traditional manufacturing technologies. Typically, and we'll talk more about this later when we get to the specific technologies, but typically additive manufacturing is good in situations where we have high design complexity, where we require rapid speed to market, and where material wastage is a big issue, because we tend to have to remove less in an additive manufacturing process. Traditional manufacturing also has its strong points in mass production, where we're producing very high volumes of similar components, where we need a diversity of materials to choose from, because they can be rather limited in additive manufacturing, and where I want to create large parts as opposed to the smaller ones that have an advantage for additive technologies. So this is an exciting space for us to think about. There's a lot to talk about, a lot to explore. Most important for you to take away is that notion of additive manufacturing and the layer-by-layer process of creating objects. We're going to see that process repeated over and over again as we explore the individual technologies that make up this additive manufacturing space. In the next module, we're going to go to Youngstown, Ohio, to America Makes, the National Additive Manufacturing Innovation Institute to explore each of these technologies, to understand their applications, their advantages, and their disadvantages.